Compression refers to the process of reducing the difference between the loud and quiet sounds for a consistent volume. It does so by reducing the dynamic range of an audio signal by lowering the level of sounds that exceed a defined threshold. In layman's terms, compression automatically reduces loud sounds so that the overall audio becomes more consistent. Compression is almost mandatory for dialogue and voiceover recordings because natural speech has a wide dynamic range. Without compression, listeners will have to constantly adjust volume. Compression helps ensure that even very quiet dialogue, such as whispers, can still be heard clearly by the audience. For example, imagine a scene where two children are hiding from a monster inside a closet. In real life, they would whisper very softly so the monster cannot hear them. The problem is in that scene, we cannot use uncompressed audio. It would simply be too soft or too quiet for the audience. The same thing also applies to scenes with lots of explosions. Imagine a scene where explosions are happening behind the characters while they are shouting at each other. In real life, those explosions would drown out their voices, but in movies, we can still clearly hear the dialogue. In both examples, we can still tell what is soft and what is loud, but everything remains within a level that the audience can comfortably hear. We don't have to keep adjusting the volume just to hear the quiet parts or to avoid the loud parts. Compression also solves this problem related to emotional nuance. Instead of focusing on the amplitude of the recording, we should focus on capturing the correct emotional nuance of the performance, even if the recording ends up very quiet. Then in post-production, we use compression to control the dynamic range. In other words, focus on the performance and nuance during recording. We can manage the amplitude later in post-production. For example, the scene requires the dialogue to be a whisper. Trying to make the whisper loud during recording would remove the nuance of it being a whisper. The performance would sound unnatural. In my dialogue sample, the dynamic range greatly varies. By the way, this is the typical amplitude of an audio level when recorded. We call this mic level. In our previous lesson, we have learned about normalization. Since the audio is too quiet, we first need to normalize it. I will just go favorites, then normalize to -3. If you don't want to use presets and want to set your own decibel level, go to Effects, Amplitude and Compression, Normalize, Process. Make sure to use decibel levels instead of percentage. After normalization, the amplitude, while louder, are still suffering from extreme variance in dynamic range.
Now, one of the big challenges with recording dialogue is that a lot of times there can be a big difference between the loudest parts and the softest parts.
There are a couple of ways on how you can handle this. First is manual gain editing. Extremely useful if there are only a handful of spikes in the audio, as we have mentioned in our normalization lesson previously. However, it is not practical if you have a clip that is long or has lots of spikes, hence why automated compression exists. For now, I will showcase the different types of compressors using the effects rack. Effects rack, amplitude and compression, single band compressor. Effects rack, amplitude and compression multiband compressor. Effects rack, amplitude and compression tube modeled compressor. A single band compressor treats the entire frequency range of the audio as one block. Any signal that exceeds the threshold triggers compression equally across all frequencies. The key idea is it compresses everything together. A multiband compressor splits the audio into 2 or more frequency bands and compresses each band separately. The key idea is it compresses different frequency ranges independently. Example. Imagine a complete loud orchestra. A single band compressor will compress the entire sound of the orchestra. A multi-band compressor will compress only specific ranges, for example, reducing the brass section without affecting the string or the woodwind instruments. A tube-modeled compressor is a single-band compressor under the hood. However, it adds analog warmth or color to the audio by simulating the harmonic distortion and subtle saturation found in classic tube hardware. A single band compressor does not add any tonal color. It simply compresses the audio. Functionally, they are the same. The difference is the sound character. As you can see, all three compressors have the same settings. Before we adjust these values, let us define exactly how these controls shape our sound. Threshold, the level where compression begins. Any signal that exceeds the threshold will be compressed. Ratio determines how much the signal above the threshold will be compressed. For every X decibels that exceeds the threshold, only 1 decibel will remain after compression, depending on the ratio setting. Attack controls how fast the compression starts. Release controls how fast the compression drops. Output gain, a flat adjustment to the overall amplitude after compression. In this lesson, we are going to use the tube-modeled compressor. Since we are primarily working with a dialogue, I wanted to add subtle analog warmth. That said, both a standard single-band compressor and the tube-modeled compressor will work. Let me delete the other compressors first. How do we actually configure the settings? We now know the technical definitions. Let's put these knowledge into practice. First, we set the threshold. The threshold isn't the same for all the audio sample. Your reference point should be the quietest parts of your audio. In this example, if we look at the decibel level meter on the right-hand side of the audio clip, the weakest spikes are at the -21 decibel, so we need to set the threshold somewhere around that. Remember, anything above the threshold will be compressed, so audio levels above it will be leveled. Let's ignore output gain for now. The ratio determines how much the signal above the threshold will be compressed. For example, with a 5:1 ratio for every 5 decibels above the threshold, only 1 will remain. In this clip, the peak is -3 decibels after normalization and the threshold is -21. The math is automatic since Adobe Audition handles it for us. The key concept is that the compressor reduces peaks above the threshold according to the ratio setting. Attack and release. In most cases, the default settings are fine, and we don't really need to touch these settings. Since we are using the effects rack, we have to press apply. Now you can see that the dynamic range is more controlled. The loud peaks are tamed, and the quiet parts are more even, but the relative variance is still audible.
Now, one of the big challenges with recording dialogue is that a lot of times there can be a big difference between the loudest parts and the softest parts.
At this point, the entire audio is now quieter. Compression reduced the peaks without raising the quiet parts, right? This is where output gain comes in. It allows you to apply a flat gain to the entire clip, either positive or negative. Personally, I do not use output gain. I do not want to calculate the exact decibels to add to get the peak level right. Instead, I will simply normalize the entire audio clip again to restore the desired level. That is why I told you to ignore output gain.
Now, one of the big challenges with recording dialogue is that a lot of times there can be a big difference between the loudest parts and the softest parts.